Let me share the screen. I didn't start. Okay, screen is now shared. Exercise 9.2, last sum we should do now. This one, fifth sum. Fourth sum is for you homework, but nobody did homework, but it's very small sum. P of A or probability of winning is 0.72. What is the probability of losing? 1 minus 0.72, that is equal to 0.28. That's all. Mental sum, that is. Okay, fourth one. What was that we were seeing in fourth sum? This one only, no? P of complementary events. P of E dash equal to 1 minus P of E2. That's the thing that you have to apply here. Very simple sum. The same way, probability it will rain tomorrow is 91. What is the probability it will not rain tomorrow? 1 minus 0.91, 0.09. Same way. That is exercise 9.2 fourth sum. Let us do fifth sum. Fifth sum only is a real sum. All other are mental sums. 9.25 now. 1,500 families were surveyed. Following data was recorded about the maids at their homes. Okay. I'm going to use Venn diagram to help you understand this. $1,500 families were surveyed. Universal data is equal to 1,500. Yeah? Or you can say N of S equal to 1,500. Now, out of that, following data is recorded. Only part-time, number of maids which are only part-time. Okay. Let us say part-time is A. Only full-time is B. Full-time is B. Both part-time and full-time will be A intersection B. Both. Okay. He's asking, this is only part-time. Only part-time means only A, not B. Okay. Only full-time means not A, only B. Okay, that is a meaning. So B is equal to 1 minus P of B is equal to 1 minus P of B of naught. Same way, P of A is equal to 1 minus P of A of naught. Okay, this is very important. This is only or not B. Okay, this is only or not A. Now, it's telling only part-time. 860 out of how much? 1,500. So, only part-time A intersection B dash is equal to 860 by 1,500. Then P of A naught only B is equal to how much? 370 by 1,500. Okay, this is n of the favorable events by n of the total sample space. Same way, n of the favorable events by n of sample space. Okay, that's how we get this. Now, what is telling is both P of A intersection B, both also is equal to 250 out of 1,500. All this data is given. Okay, family selected at random. Find the probability the family selected as both type of maids. Family selected as both type of maids. Then family has part-time maids. And family has no maids. Okay. Now let us do third one. Family has no maids. It is having only you can do this way. Put the diagram like this. It's having okay. Those are having only part-time. This is A, this is B. Only part-time is 860. Only full-time is 370. Both part-time and full-time is 250. Okay. So total is 1500. Now what you have to do? 850 plus 860 plus 250 plus 370. How much? This is A union B. Will be A union B. 5 plus 12, 5 plus 7, 12, 12 plus 6, 18. 8 plus 1, 9, 10, 11, 12, 13, 14, 1480. Okay.
1480.
One made is 1480. That means union minus A intersection B. N of union minus N of A union B. That will give you number of families with no mates. Alright. Because that is 1500 totally minus 1480. That means there are 20 families without any mates. Okay, so here you have to put 20. Third one is settled now. Find the probability the family has part-time mates. Total number of part-time mates. And the probability that the family selected as part-time mates only. Now A was part-time. Okay, so part-time mates. N of B is part-time. N of A is equal to 860 divided by N of S is equal to 1500. Okay, that only you have to do. Cancel 0, 0. 86 by 150. 43. This is by 2, 7. So that is equal to 43 by 75. It has only part-time male. Probability of only part-time males. Family probability that family has this one. Okay. Then let us go to the first one. Where is asking first one? Both type of mates. Is having both type of mates is equal to N of A intersection B divided by N of the sample space is 1 by 1500. This will go inside 6 times. So that is equal to 1/6 is the answer. This is probability family has both type of males. Both type of males. Okay, this is the real sum that you have. Otherwise, there is nothing there. Find the probability that there are no mates. Okay, we didn't finish this. Only enough mates, 20 families we got. Okay, so probability of no mates is 20 divided by 1500. 2 divided 1/5, that is equal to 1 by 75. So probability of no mates. Okay, that's all. You understand this, huh? If you watch the Venn diagram, you will get it very clearly. A union B is what? A union B is this entire space. Understand? Okay. Now the mates that are left out, the space. All right. So Union minus P of A union B. This space is what? Nothing but this entire thing is P of A union B. Correct. So P union A union. That is what you are finding out. The total of P of A union B is equal to 1480. Union is 1500. Total number of families. So 1480 families at least have one male. Okay. That will give you 20. That's what you got. Then probability of that is n of no mates is equal to 20 divided by total sample space of the families is 1500. 1 by 75. Okay, you got that. Any doubts on this?
No,
Guys, are you
uncle.
listening? Went to sleep? 3 o'clock is more relaxing time. Nobody's
No
answering.
doubts, uncle. Uncle.
We're all here only. Any questions on this, guys? This is the really important sum in that whole thing. The other one, fourth sum, is very easy.
I think he can't hear us.
Sandhya, what? Anything you have to say? You are understood. If you are silent, then I means I am assuming you understood. Arpana, you understood?
Yes, uncle.
Oh.
Can you hear us now, uncle?
Yeah, we can hear you now.
Okay.
Oh, shucks. You are talking till time. You understood that?
Yes, uncle.
Okay. Oh, this audio was blocked. I don't know how it got blocked. Okay. That's why I was wondering. You guys usually answer well. Okay. So that is the sum. Very easy. You put a Venn diagram, you will understand it very easily. Okay. If you don't put a Venn diagram, it will be slightly difficult to understand. Okay. Let us go to exercise 9.3 now. These are all mental sums. You can easily say what are mental sums are. Okay, multiple choice questions. Exercise 9.3. Let us do 1 now. A number between 0 and 1 that is used to measure uncertainty is called what? Random variable, trial, simple event, probability. What is it called? Tell me, guys. Number between 0 and 1 that is used to measure uncertainty is called? What happened?
Probability, uncle.
Yeah, probability. Why you are thinking so much for that?
No, uncle, I was in mute. I didn't know I was in mute, uncle.
Very simple, probability. That's what you have been learning all the time. 4 probability. Okay. Second one. Probability lies between -1 and +1, 0 and 1, 0 and n, 0 and infinity. Which one?
0 and 1, uncle.
0 and
0 and
1.
1.
Very
Option
good.
2, uncle.
Very good. Option 2. The probability based on the concept of relative frequency theory is called? This one, very small detail they gave on relative frequency. Okay, classical probability, you don't have relative frequency theory. Only which probability you have relative frequency theory. You have to find their relative frequencies. Which one? Which are the two types of theories? Classical probability and empirical probability. Okay. Which one is based on relative frequency of the, say, the defects are occurring, like that? See, you forgot.
Depends on research, uncle.
Page 295 at the end of the classical approach. You are starting last paragraph. Turn to
Yes,
page
uncle.
295, last paragraph. What does it say there?
The empirical approach, relative frequency theory.
Ah,
Probability holds that if an experiment is repeated,
exactly. So what is the answer for question number 3?
empirical probability.
Empirical probability, correct. Don't forget that. It's only a theoretical question. Okay,
Yes, ma'am.
it's only a theoretical question. But that's where some small gap they asked you. Now you should not blink like that. Remember that. So only empirical probability is based on relative frequency. Okay. Fourth one, let us ask. Probability of event cannot be equal to 0, greater than 0, equal to 1, less than 0. Which one is correct? Cannot be. P cannot be equal to 0. P cannot be greater than 0. P cannot be equal to 1. P cannot be less than 0. Which one is correct?
Equal to 0.
Why? P can be equal to 0. P equal to 0 means impossible event. Event will never occur. P can be equal to less than or equal to?
Equal to 1, uncle.
Equal to 1 means what? What you guys are learning? This is a certain event. The event will surely
Less than
occur.
1, uncle.
Less than 1. Probability cannot be negative. It cannot be more than 1. It cannot be 1.2 or it cannot be minus 0.2. What? Yeah, simple things and all you are thinking so much. That means it is not entered properly. You have to revise. The very simple probability chapter, very simple chapter. Okay. It cannot be less than 1. Probability of all possible outcomes of a random sample experiment is always equal to P of sample 1, E1 plus P of E2 plus P of E3, like that till P of En. See, suppose you are having 1, 2, 3, 4, 5, 6. Okay, the probability of each of these event is 1 occurring is 1/6, 2 occurring is 1/6, 3 occurring is 1/6, 4 is another 1/6, 5 is 1/6, 6 is 1/6. What is the total of all of this? 1/6 plus 1/6 plus 1/6 plus 1 plus 1 plus 1 plus 1 1 plus 1. How much? 6/6 equal to 1.
1.
You are thinking,
Option
you are not
1.
able to say. That means you are not understood this lesson. We are almost finishing it, and you are one day holiday means you forgot everything, or that's the reason, Friday we didn't meet, so you forgot everything. You can't forget like that. The probability of all possible outcomes, everything in the sample set is coming. Every event or every outcome in the sample set is coming means the probability is equal to 1. Okay, everything is covered. P of the event is equal to 1. Okay, now let us go 6 sum. If A is any event in S and its complement is A dash, then P of A dash equal to A dash or A complement or A bar, whatever, is equal to what?
1, uncle.
I think you don't understand anything. We finished the lesson, now you are telling like this. You never understood anything.
1, uncle.
To make you understand. Hello friends, you have not understood what is complementary event. There are two events, A and A dash. A is the event occurs. A dash is the event does not occur. Okay, like this. This is A, this is A dash. Everything else is A dash. This is A dash. Please tell me what is the answer. Very simple
1
sums.
minus P of A, uncle.
Pada. Finally, you are telling. P of A complement is equal to 1 minus P of A. That's what you have been using in this sum. The probability of winning is 0.8. What is the probability of not winning?
1 minus 0.8.
1 minus 0.8. How much that is? 1 minus 0.8. How much?
0.7.
Huh? How much?
0.7.
0.2.
Yeah, you are having problem in addition, subtraction, everything. For standard itself, you are having problem. 9th standard, what to do? Why today everybody out of form, not telling correct answers? 3 o'clock, I think not good time to take then. 4:30 only good time. Okay, let us do 7th sum. 7th sum. Which of the following cannot be taken as probability of an event? 0, 0.5, 1, minus 1, which is not probability. Oh, guys.
Minus 1.
Oh, you are thinking so much here. As soon as you see minus 1, it cannot be probability. It's only from 0 to 1. Okay. Let us do 8th sum. A particular result of an experiment is called what? Result of experiment is called what? Trial, simple event,
Outcome, uncle.
outcome. Very good. Very good.
Outcome, uncle.
Outcome. Very good. Yeah. See, experiment is the same as trial. You throw a coin once or you throw the dice once. That is called experiment. That is also called a trial. Okay.
Yes.
Then there is nothing like simple event and compound event. They are simply confusing you. You didn't learn anything called simple event and compound event. There are mutually exclusive events. There are equally likely events. There are complementary events. Like that, events are there. Nothing like simple event, compound event. So outcome only is correct. Okay, let's do 9 sum now. A collection of one or more outcomes of an experiment is called
Event.
very
Event.
good. Very good. Okay, suppose you have collection of sample space. Now this is sample. Okay, experiment has been done. Sample space is this. Event is getting even number. Even number. What is the collection of one or more outcomes for getting even number? From the sample set, what is the collection for getting even numbers? Set of even numbers. Event is what? Or you can put
3, uncle.
Huh? No,
Three.
I'm telling you, tell me, this is the sample space. This is
Yes,
all the outcomes 1, 2, 3, 4, 5, 6 when you throw a dice. What is the event of getting even number?
3 by 6.
3, yeah. Okay, probability is 3 by 6. What is the event? Event A. Event A is a set, right?
2, 4, and 6, uncle.
Collection of one or more outcomes. 2, 4, and 6. Yes.
4.
You're not understood, digested these things. You're not enjoying the probability language. What is meant by experiment? What is meant by trial? What is meant by event? That's why all this is given. Okay, let us do 10th sum now. The 6 faces of the dice are equally likely if the dice is
Air, uncle.
fair. Yes, you must have a fair dice. Otherwise, it will be biased dice. Okay, biased dice you can't. You cannot have a round dice. All dices are 6-faced, and small dice, big dice, and all does not matter. Fair dice. Okay, very good. With that, I want to congratulate you guys. You have finished probability. Okay. Now we are going to go on to coordinate geometry. Okay. So all the 4 small lessons you have finished. These are the easiest lessons in your textbook. If you are struggling with these easy lessons, then what you will do with the main lessons? First 5 lessons are main lessons. They are not so easy. They are longer lessons also. Let me put this in your WhatsApp and then we'll go to coordinate geometry. So let us go to coordinate geometry. You have to open page 185. Page 185. Yes. French mathematician René Descartes. Descartes developed a new branch of mathematics known as analytical geometry or coordinate geometry. It's a very interesting kind of geometry which combines arithmetic, algebra, and geometry of the past in a single technique of visualizing as points on a graph and equations as geometrical shapes. Okay. Now, equations you have in algebra. Okay. But he's bringing algebra here in order to define the shapes like a line or a square or a triangle. Okay, you are giving equations or a circle. For all these shapes, he is giving algebraic equations in order to represent them. See, very clever. And for point also, he is giving equation. How to get a point on a plane? By assigning two numbers. For assigning two numbers, you need x value and y value. That means you need x-axis and y-axis. So every point has got two coordinates. Okay, two numbers. Usually they are written as any point is written as xi, yy. Okay, you can write it as 5, 1. That is one point. Okay, how it is coming 5, 1? X-axis, y-axis. 1, 2, 3, 4, 5. 1, 2, 3 is going on. See, 1, 2, 3, 4, 5. And y-axis 1. This is gone here, this is gone here. At the meeting point, you have 5, 1. You understand? Very easy. Have you learned this before?
Yes, uncle.
Yes, uncle.
8th standard, you learned that.
Graph.
These fellows are creating so much noise above my head. They're doing interiors. God knows when these idiots will stop. Anyway, let us go on. Are you getting too much sound? No, no.
No, uncle, we're not getting any noise.
No.
Then no problem. Okay, what are the learning outcomes? To understand the Cartesian coordinate system. Because his name was René Descartes, okay, this method that he has used is called the Cartesian coordinate system. Okay, to identify the abscissa and ordinate and coordinates of any given point. Okay, we have to see what is abscissa, what is ordinate, and what is coordinate of any given point. To find the distance between any two points in the Cartesian plane using some formula. Okay, suppose the distance is given between one point and another point. So this is 5, 1. And let us say this is another point 1, 3. What is the distance between these two on the x-axis and y-axis? If this distance d, how to find that? No, that we are going to do. To understand the midpoint formula and use it in problem solving. Then another thing is how to find the midpoint of a line. Okay, given this points 1, 3 and 5, 1. How to find the midpoint, and that also there is a formula. So again, formula is there for distance between 2 points. Okay, then to derive the section formula and apply this in problem solving. Okay, then there is something called section formula. We have to see what that is. To understand the centroid formula, that is for you have triangles. From here you join the opposite midpoint. From here you join the opposite midpoint. From here you join the opposite midpoint. This becomes what? This is called the centroid. All right. So he's telling how to get the centroid formula. If you are given A is x, y, B is A, B, and C is P, Q. Okay, you can get the value of the x coordinates and y coordinates of the centroid. That is formula possible. Okay, very interesting. Now he's telling how you write the address Here is one. Sarakal Villai Primary School, 135 Sarakal Villai Housing Board Road, Kira Sarakal Villai, Nagarkoil 62900, Kanyakumari District, Tamil Nadu, India. Okay. From India is going into Tamil Nadu, from that into Kanyakumari District, from that into city Nagarkoil. Inside Nagarkoil, a suburb called Sarakal Villai, Kira Sarakal Villai. That side, inside that place, there is a road, Housing Board Road. Okay, like that. And finally, in house number. So big one to small one to small one to small one, you are going like that. Like that, smaller and smaller and smaller. Finally, you are finding the address. Okay. Now, with that, what he wants to teach us? Somehow this information is enough for anyone in the world from anywhere to locate the school one study. Okay. So that the amount of information is enough for anywhere, anybody. You don't know, across the globe, you can find that place very easily. Now, just consider these are crores and crores of buildings on the earth. Okay. There are crores and crores of buildings on the earth. Yet we can use an address system to locate a particular person's place of study, however interior it is. One fellow here is now studying in a school building, very interior in some south area, remote area inside Nagarkoil. He is able to find out with that address. How is this possible? Now let's work out the procedure of locating a particular address. We know the world is divided into countries. One among them is India. So as soon as you say India, India is divided into states. Among these states, we can locate our state, Tamil Nadu. Okay. Further going deeper, we find our state divided into districts. So districts are divided into taluks. Taluks are divided into villages. So when you go down Sarakal village, you can easily find out among the villages in that taluk. And among the roads in that village, Housing Board Road is a specific road. Okay. So finally, we end up the search by locating the primary school building because the door number 135, that is the last thing that you are finding out. Okay. And so that is so simple. In the New York City of USA, there is an area called Manhattan. The map shows avenues run in the north-south direction and the streets run in the east-west direction. North-south direction avenues run. Okay. In Anna Nagar also you have avenues, no? In Tamil it is called Nilarchale. Nilarchale means a lot of shaded trees are there and you have a road. Lot of shaded trees are there, you have a road. That is avenue. See how avenue is running? Avenue is running. This is second avenue running like this. This is third avenue running like this. So sixth avenue is running like this. You understand? It's all running in the north-south direction. Okay, then streets are running. 4th street is running like this. 57th street is running like this. 23rd street is running like this. So these are running in east-west direction. Understood? Okay. So if you know the place you're looking for is on 57th street, between 9th and 10th avenues, you can find it immediately on the map. Okay. So 3rd Avenue, 48th Street. What street you want? 57th Street. This is 57th Street. So it is there. And between 9th and 10th avenues. This is 9th Avenue, this is 10th Avenue. So this area only it must be, this small area only. You can easily find it. From the door number on a street, you can actually calculate which avenue it lies between. So they are having door numbers, and from the door numbers, you can calculate which are the avenues it is lying between. So all maps do just this for you. They help us in finding our way and locate a place easily by using any information of any landmark which is nearer at search to make us understand whether we are near or far, how far we are, or what is in between, etc. So all this is done in the maps. Now what we have to do, globally how we are going to do this? We are using numbers to map the places. Okay. So the idea of using numbers to map places comes from geometry. Mathematicians want to build maps of planes, solids, all kinds of shapes. Planes not aeroplanes. Okay. We are talking about a plane is a two-dimensional surface. Okay. So you want to build maps of this two-dimensional surface. Then you want to build maps of the three-dimensional surface, shapes and of all kinds. Why they want to do this such maps? When we work with a geometric figure, we want to observe whether a point lies inside the region or outside on the boundary. Okay. So point is lying inside or point is lying outside. You want to find out. Given 2 points on the boundary, or point is lying on the boundary, like this, points are lying on the boundary. Given 2 points on the boundary and a point outside, we like to examine which of the 2 points on the boundary is closer to the one outside. Okay, whether this point is closer to that one or this point is closer to that one outside. How much closer, if so? This is, let us say, this is 5 units, this is 6 units. That means that is 1 unit closer. Like that, okay. With solids like cubes, you can imagine how interesting and complicating such questions like can be, okay. Mathematicians, they ask such questions and answer them only to develop their own understanding of circles, polygons, and spheres. Sphere is a solid. Circle is a plane. Okay, it's a planar object. Okay, it's only a polygon is also planar. Okay, because pentagon is a polygon, hexagon is a polygon. It is only 2-dimensional, but sphere is 3-dimensional. All right, sphere is 3-dimensional. Mathematical tools and techniques used for find immense applications in day-to-day life. Okay. Now, all these tools that they use, they're very important in day-to-day life. Okay. For example, our Earth. How we are mapping our Earth? We use latitudes and longitudes. Okay. Latitudes are these lines. Longitudes are these vertical lines. Okay. Madras in the latitude, in the longitude, intersection. Okay. So the coordinate system was developed in the 17th century, which means in 1600s, coordinate geometry was developed. Only based on that, therefore, in 1700s, latitudes and longitudes were developed in the 1700s. 18th century means 1700s. You already know the map of the real number system is the number line. It extends infinitely on both directions. Okay, we have learned that number line. 0, 1, 2, 3, like that, 5, 6 it goes. -1, -2, like that it goes this side. Okay, you already know. That is a map of the real number system. That's a number line. It infinitely extends on both sides. In between any 2 points on a number line, there lies infinite number of points. Okay, how many points are there between 0 and 2? And 0.1, 0.2, 0.3, like that. You can go even down 0.003, 0.00001, like that you can go. So there are infinite points between 2 points on a line. Now we are going to build a map of the plane so that we can discuss about the points on the plane and the distance between the points, etc. We can then draw on the plane all the geometrical shapes we have discussed so far. Okay, that is what we are going to do here. Only when you start discussing a actual example, you will start understanding all this. Look at this diagram, no? Arithmetic introduced us to the world of numbers and operations on them. What is arithmetic done? See, arithmetic, algebra, geometry, everything is brought together in coordinate geometry. This is A that is used. Arithmetic is used. Geometry is used. Okay, algebra is used. B that is used. Geometry C. A plus B plus C. All things are used together to do analytical or coordinate geometry. Okay, yeah. Algebra taught us to work with unknown values and use equations. Geometry taught us to describe shapes by their properties. Okay. Coordinate geometry will teach us how to use numbers and algebraic equations. See, all this arithmetic you will use, all the algebra you will use. You will use that to study geometry, and there is an integration of many techniques in one place. Okay. It's also very, very much fun, he's telling. Yes, it's actually fun, because you are integrating arithmetic, algebra, and geometry inside geometry now. devising a coordinate system. Now we are getting into the real thing. Okay. You ask your friend to draw a rectangle on a blank sheet of paper, 5 centimeters by 3 centimeters. Okay. Let us say this is 5 centimeter by 3 centimeter. But he says, sure, but where is this sheet? Where on the sheet? How would you answer him? See, you're giving him a A4 sheet and you ask him, okay, draw a rectangle on a blank sheet of paper, 5 centimeters. You can say, draw here, or draw here, or draw here. Where to draw? Okay. So, how will you answer him? How will you answer him? Look at the picture. How will you describe to another person this picture? Some typical town in India. Typical town in India. It looks like that. You go to Bombay and you are going by train. Then you cross over to New Bombay, Navi Mumbai. Before that, you will see on the sides of the train so much of slums like this. Okay. Let us analyze the given picture. Just like a particular house is to be pointed out. It's a difficult task. Which house? Instead, if any place or an object is fixed for identification, then it is easy to identify any other place or object related to it. Okay. First, you fix one object. Okay. This is the center point. Fix panigo. Once you fix that, then you can point out other objects relative to that. All right, now you can, as shown in figure 5.4, draw two perpendicular lines in such a way that the flag is pointed out at the or out at near the intersection point. Okay. This flag, no? You understand? There is a blue color flag there. Okay. That flag is there. Huh? You fix the flag and then talk about the house to the left of it, the hotel below it. See, this is a hotel. The house that is left of it, this house is left of the flag. Like that you can talk. Okay. The antenna on the house to right of it. Okay. You can talk about that. There is a house to the right of it. I am not able to see the antenna. Are you able to see the antenna? Something is telling. I don't know where. This is dish antenna. Probably this one. Dish antenna. He's thinking of that. So antenna to the house right of it. Like that you can talk. Okay. Now, where are we getting at? Why all this? If you tell your friend the total length and width of the picture frame, keeping the flagpole as landmark, you can also say 2 centimeter to the right, 3 centimeter above. Since you know the direction, you can also say 2 centimeter east or 3 centimeter north. That becomes even more precise. You can say go 2 centimeter, 1, 2 to the east, and then go 1, 2, 2 centimeter to north. There you will find the dish antenna. Okay. 2 centimeter, you go east of the flag, 1, 2, like that. Then 2 centimeter north. Then you have the dish antenna, very easy to find out. So that's what we are going to do. A number line is usually represented as a horizontal line on which positive numbers are lying on the right side of 0. You already know how to, you have seen number line. Okay. Now we are going to use two number lines here. Okay, that's what you are going to do. Now, where will these two number lines meet? Okay, there is one number line, 0, 1, 2, 3, 4, all of that is going to, this number line will extend infinitely. On the negative side also it extends infinitely. Negative side becomes -1, -2, -3, -4, like that it becomes. Okay. Where do the two number lines meet? Obviously at 0. This one is 1, 2, 3, 4, like that it goes to the top, towards north. This one is -1, -2, -3. It keeps going towards south. This is towards east. This is towards west. Okay. Now, once you have this, we can talk about other numbers related to the 0, 0 on both lines. So now you can talk about everything. Suppose you go to 2 on the right and 3 on the top. You go to 2 on the right and 3 on the top. You come here. Okay. We would call this place 2, 3. That's all. Understand? Or 2 this way and 3 this way. Okay. Very easy now to understand. All this vertical up, horizontal side and down, it's all very cumbersome. So we just say simply 2 by 3 and understand this as 2 to the right and then 3 upward. Okay. See this diagram. 2 by 3 nale 2 to the right and 3 to the up. That's what it means. Okay. Or you said 3 up and then 2 right also, you will reach the same place, but it's not the same as instruction 3, 2. Okay, that is where you must stop. Okay, conventionally, you must put the x-axis first and y-axis second. So 2, 3 means on the x-axis travel 2 times, on the y-axis 3 times. So 2 distance on the x-axis like this, and 3 distance on the y-axis like that, you arrive at the point 2, 3. This is the convention. You cannot say I will go 3 like this and 2 like that and reaching the same point. So the same point is 3, 2. No, the same point is not 3, 2. Because by convention, only the x value comes first and then the y value comes next. Okay. And from where to? From where 3? Always from 0, 0. Okay, every point is taken from 0, 0. This is 0, 0. Okay, always from 0, 0. Now what else we need? We need names for the horizontal and vertical number lines. Okay, let us call the horizontal number line the x-axis and vertical number line y-axis. That's very important. Okay, this is called x-axis. This is called y-axis. This is 0, 0. Yeah. And to the right, we may mark as x, to the left as x dash. Now you mark x here, and then you mark x dash here. Now you mark y here, and you mark y dash here. Okay. So x0, x dash is called the x-axis, and y0, y dash. Okay, y0, y dash is called y-axis. Okay. Now the x coordinate is called the abscissa. Okay, in this 2, 3, this is called abscissa. Okay, abscissa. And y coordinate is called ordinate. That's all. And the meeting point of the x-axis is the origin. This one 0, 0 is called origin. Okay, this all you have to remember. That's all. Now you can start enjoying the wonders of coordinate geometry. Abscissa and ordinate, x-axis, y-axis, x dash, y dash, x-axis, y-axis. Then origin is 0, 0. Then any other point 2, 3 is having 2 is abscissa and 3 is ordinate. Y-axis distance is ordinate, x-axis distance is abscissa. Okay. Simple, no? So far, no issues. Okay, simple. Now you can describe any point on the sheet of paper by a pair x, y. However, what do 1, 2, etc. mean on paper? We need to choose some convenient unit and represent these units. Either one unit will be 1 centimeter, okay, or 1 inch, like that. 2, 3 is the instruction to move 2 centimeter to the right of 0, 0 and 0 and move 3 centimeter up. Okay. So when you write A is 2, 3, a point A is 2, 3, that means from the 0, 0, which is the origin, move it 2 places to the right and move it 3 places to the up. Okay, so this is A 2, 3. That is the meaning of that. Now, once you have got this, you can plot exactly where you want the thing to be written on or drawn on your paper. And you have to take units also. Okay, usually you take 1 unit is 1 centimeter. This is equal to 1 centimeter or is equal to 1 inch. You can take, or sometimes very long numbers, you can take 1 unit is equal to 10 centimeters. That is also possible. We'll come to that later. So this choice of units is arbitrary. Arbitrary means what? Chuma, you have given yourself. Okay, there is no rule what you should give. We have taken it as 1 centimeter. One distance is 1 centimeter, 1 unit. If we fix our one unit to be 2 centimeter, our figures will be larger, but the relative distance will remain the same. Okay. So now you have a language to describe all the infinitely many points on the plane, and not just on a sheet of paper. Any plane, infinite number of points are there. All those points can now be named. Okay, you got a language. That is the language of coordinate geometry. Since the x-axis and the y-axis divide the plane into 4 regions. 4 means quad, right? You call them quadrants. That's all. Okay. Quadrilateral, what is quadrilateral? 4-sided figure is quadrilateral. So quad means 4. So this is quadrants, meaning there are 4 planes inside the single plane. Remember, no? That way. So usually numbered as quadrant 1, 2, 3, and 4. Okay. Now you should remember, this is 0, 0. Okay. This is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. It comes in the anti-clockwise direction. Okay. Very important. It comes in the anti-clockwise direction. For upper east side 1, upper west side 2, lower west side 3, and lower east side 4. This is the one. Upper east side 1, upper west side 2, lower west side 3, lower east side 4. Okay. See, then he's asking one question. Why this way anti-clockwise? Why not do clockwise and not starting from any of the other quadrants? This does not matter at all. Okay, it is only a convention. This is what you have been doing for a few centuries now. So you also follow that. If you are going to say, no, I'll keep different name. This is quadrant 1, this is quadrant 2, this is quadrant 3, quadrant 4. Then you will be all wrong because convention says that this is quadrant 1, 2, 3, and 4. That's the whole point of that. Okay. So region X, O, Y. Okay, region X, O, Y. So it is like that. This is X dash, this is X, this is Y, this is Y dash. Okay, the region, this is X. Okay, X, this is origin Y, this region. It is called quadrant 1. Okay, in this quadrant, both X is greater than 0 and Y is greater than 0. Okay, 2, 5, for example. Move 2 to the right and move 5 to the left. 2, 5. It will be like that. Okay. Then what you will get? Let us take the Are you following, guys? All very quiet, no doubts, nothing. Anyway, we have not started the examples. Okay. This is X dash, this is X, this is origin, no, this is Y, this is Y dash. Okay. Here anything will be plus X comma plus Y. Okay, X will be greater than 0, Y will be greater than 0. Here what will happen? X dash will be negative. Okay, minus 1, minus 2. So minus X comma Y. Y will be positive. Okay, so X is less than 0, Y is greater than 0. Here, both X is negative, Y is also negative. Okay, this is second quadrant. X alone negative, Y positive. Okay. Here what is happening? This is third quadrant. This is first quadrant. Here, both X is negative and Y is negative. So X also less than 0, Y also less than 0. So minus 1, minus 2, minus 3, minus 4 like that. Okay, minus 2, comma, minus 4, this point. Minus 2, comma, minus 4, this point. You can understand? Minus 2 on the x-axis first. First move on the x-axis minus 2. Then move -4 on the y-axis. You get this point. Like that. This is the point. Then what? Fourth quadrant. Fourth quadrant, what happens? X is positive.
X is positive, Y is negative, uncle.
Very good. Y is negative. Super, yeah. Very good. Yeah, fourth quadrant. That means 2 comma -5. And 1, 2 is here. -5, that says -5. 2 comma -5 will be here. This point is 2 comma -5. So X is positive, Y is negative. As you keep on using the coordinate system, you will automatically recognize this. Okay. Here both are positive, positive. Here both are negative, negative. Here there is positive, negative. Here there is negative, positive. That's all. Okay. That's all. Just remember like that. One quadrant is positive, positive. Three quadrant is negative, negative. The other
Uncle,
two are.
second quadrant is negative and positive, uncle.
Which one?
Second quadrant.
Second quadrant is negative, positive. Correct. Negative, positive. The fourth quadrant is positive,
Positive, negative.
Positive, negative. Yes, very good, very good. Yeah. Now let us go and see something else that they have written. This diagram they are showing. So positive, positive is first quadrant. Negative, negative is third quadrant. Negative, positive is second quadrant. Positive, negative is fourth quadrant. Very simple. So for any point P on the x-axis, the value of y coordinate is 0. Okay. Let us take one point on the x-axis now. One point is on the x-axis. Okay, I'm taking this one. That means this is equal to 3. Where is y? How much is y? Y is equal to 0. 3 comma 0. That's what is meaning. For any point P on the x-axis, the value of y coordinate or the ordinate value is 0. That is P is x comma 0. So if I say 5 comma 0, okay, I am meaning point here. This is 5 comma 0. Okay, or -5 comma 0. I am meaning here, or -3 comma 0. -3 comma 0. Okay, whenever y is 0, the point falls on the x-axis. Same way, whenever the point is on the y-axis, x coordinate or abscissa is 0. Okay, what is this? 0 comma 3. What is this point? 0 comma -2. Okay, x is 0, -2 is -2. Y is x comma y. So like that. If it is on the y-axis, then abscissa will be 0 and will fall on the y-axis. And very important, as I told you, point x comma y is never equal to y comma x unless x and y are same. Okay, 5 comma 2 is never equal to 2 comma 5. Not equal to. This is 5 comma 2. 5 comma 2 is here. This is 5 comma 2. Okay, 2 comma 5 is 2 comma 5. This is 2 comma 5. 2 comma 5. Okay, these two are not same points. 5 comma 2 is A, 2 comma 5 is B. They are two different points. Okay, so if you cross x and y, it means the same point. Don't think it is not the same point. It's a different point. A plane with a rectangular coordinate system is called a Cartesian plane. This entire area, your graph sheet, no? That graph sheet is a Cartesian plane. Okay. Now very slowly they are bringing in. You also let us go very slowly, understand and enjoy. Now, how to plot points on the coordinate, on the Cartesian coordinate plane. So they might ask objective question, what is a coordinate plane called? You must not blink. It is called Cartesian plane because René Descartes was the one who invented it. We'll just do this and finish. We are already reaching 4 o'clock. To plot the points 4, 5 in the Cartesian coordinate plane, follow the x-axis until you reach 4 and draw a vertical line at 4. Okay, 4, 5. How to draw 4, 5? Very simple. Okay, 1, 2, 3, 4. Go here and then you draw a line. Draw a line. Okay. Okay. Draw a vertical line x equal to 4. Okay. This vertical line is called x equal to 4. Okay, because it includes. Then follow the y-axis until you reach 5 and draw a horizontal line. This line you draw. This line meets this point. Okay. So the meeting point or intersection of the two on the Cartesian plane is the position of 4, 5. So this point is at a distance of 4 units, okay, from x-axis, and it is a distance of 5 units from the y-axis, okay, 5 units from the y-axis. This is the way 4, 5 is located in the Cartesian plane. Understand? Very simple. Very simple. You guys are understanding at the time when I am teaching. After that, you are forgetting. I don't know what. Once you understand, you cannot forget. You should retain it. Now, example 5.1 they are given. You guys tell me the answer. In which quadrant at the following points lie? Arpana, you tell me first one. 3, -8. Which quadrant it is lying? 1, 2, 3, or 4?
Quadrant number 2, uncle.
4,
Quadrant
uncle.
number
4, uncle.
4. Yes, very good. Correct. Okay. Sandhya, you tell me -1, -3. Which quadrant?
Quadrant.
Third, uncle. Third quadrant.
Third quadrant. Correct. Minus பார்த்தாலே third quadrant. Plus பார்த்தாலே என்னது?
First quadrant.
First quadrant. The other two only you will have to think a little bit. Plus and minus. Okay, x is plus minus na. அப்பனா இது second quadrant அப்படின்னு போடணும். 3, -8. Okay. இது வந்து -7. Okay.
Fourth, uncle. Fourth quadrant.
Fourth quadrant. Very good. Fourth quadrant. It's because -7 is going this way. -7 is here. Okay. Then 3. You're going -7 here. X is -7. Then you're going 3 this way. So how much is that? -7 you're gone and 3. This is second quadrant. What did you say? The second quadrant, -7, 3. Then 3, -8. What is that then?
Second quadrant, uncle.
3. You're going for 3, -8. 3 you're going, -8 you're going. 3, -8. How much? Which coordinate it is?
Second, uncle.
I'll draw one more time. This is x dash. This is y dash.
Fourth quadrant, uncle.
3, 1, 2, 3. Then 1, 2, 3, 4, 5, 6, 7, 8. 3, -8 is this point. Fourth quadrant. Yeah. That's why I told you. Okay. Minus and minus, all immediately third quadrant you can say. Plus and plus, immediately first quadrant you can say. Okay. Plus and minus, you have to go for fourth quadrant, not second quadrant. Minus and plus only, you have to go for second quadrant. Okay. Okay, example 1, 5.1, you yourself solved. We don't need to read that. Let us go to example 5.2 now. Or we'll finish, we'll come back again. Okay. Anyway, we started no homework today. We just read example 5.2 and come.
Okay, uncle.
Okay. Bye, guys.
Bye, uncle.
Bye.
Bye,
One more thing, guys. Wednesday we won't have class. I forgot to tell.
No.
I'll have to be out for a conference. Okay. Wednesday we won't have class. That class I'll compensate for you on Saturday. Saturday, what time you are free? 11 to 12 you are free? Saturday
Can
morning?
you change it to 12 to 1, uncle?
Okay, 12 to 1 also okay. Both of you are okay with 12 to 1?
Because I'll be having online classes, uncle.
That's why I'm asking. What time we can have? 12 to 1 we can have?
Yes, uncle. That's okay.
Where did... Oh, Arpana, where you go? She went off.
Yes, uncle. She left, uncle.
Oh, 12 to 1. You have to ask her. Okay, no problem. I'll put it on the...
WhatsApp.
Yeah. Friday we'll have class.
Okay, uncle.
Okay, bye. Yeah, see you.
Bye,
All the
uncle.
best.